Let me, I can send you a link. Okay, link is posted in the chat. Okay, cool. So before we go into this, I want to share a little bit about, I want to do a quick reminder of why we explore, what we have done up to this point. Um, so let me share my screen. So if you look at our at the curriculum and you go to fundamentals and you look at the pipeline demo, not the demo, my bad, and you look at the data science pipeline, right? You see we've got the planning, acquisition, prep, exploration, and pre-processing, modeling, and delivery. So we worked on in classification. We have been working on going through each of these steps, and again, as we go through the next methodology and the next methodology, we'll add complexity to each of the steps. Okay, um, but the framework that we're establishing will remain the same. Okay, so you'll just kind of be filling in more pieces, adding more details to the phase. So we've acquired, you've prepared, which means like missing values, looked at outliers, kind of decided what to do with any outliers. We have not really run into any in this case, right? But we'll get there. There's things like that we'll do in regression. We'll scale the data, right? We'll make sure that our numeric data are all in the same units. So we're not comparing the importance of pupil size to height, because height is going to appear much more important. And maybe, maybe it shouldn't be in whatever we're modeling. I don't know. Things like that. And then we get to exploration, right? And if you look at this pipeline, why do we explore? Well, we want to understand what's going on in our data. Our computer, the algorithms that we feed it, all of these things can only do as much as we know how to tell it what to do. Okay, so we need to understand our data enough to know, at a minimum, when something gives us something that doesn't make, when we return something that doesn't make sense, at a minimum. But we really need to be able to speak to the data. We need to be able to explain what's going on, even if all we're delivering is a machine learning model that no one is ever going to care about how it works underneath. We need to know. We need to be able to troubleshoot it. We need to be able to explain why the output came the way it did when it's like someone reached out to a customer and it was completely wrong and they shouldn't have, but our model told it to, or something like that. We need to be able to understand those things. Besides the point that most likely the job you go into right after this is going to involve reporting. It's going to involve doing the really creative, interesting work of analyzing the data, understanding what's going on, and making recommendations of how we can improve. And that's where it all happens in exploration, most of it. So it's about visualizing. It's about statistical testing when our visuals don't tell us exactly what we need to, or it doesn't give us enough information, or maybe it's unclear. Like it looks like there might be something going on here, but I'm not quite sure. It's about finding features. And what do I mean by that? What I mean is we gather the data, we gather the variables, the information that is acquired at some point in our business's history or process, right? Data is captured in all these various points. That doesn't mean that that data that's captured in that way is going to lead us to the insights that we need, right? Those insights, that data, it might be um, it might be so ugly and so messy that it's hard to see anything of value in it. Think about a stop sign that is hidden behind the shrubbery and you can't see it. I think about that as that is a signal that is hidden by all the noise. And whether it's human eyes looking at it or a computer looking at it, it's going to be hard to see, but it's there, right? We need to help the algorithms that we are going to give it. We need to help to be able to see the signal. So we need to trim away that shrubbery. And that's what exploration is for. It's to help us think about the data, understand what's going on, make the signal clearer. How can we make the signal clearer? We can remove the stuff that doesn't matter. We can remove the redundant stuff. We can create new variables that may highlight the information that's most interesting. And that's what we're trying to do in exploration. Okay. That's why we explore. In the simple version, it's how do we do it? We hypothesize. We formally hypothesize, but mostly we informally hypothesize. That means like, I wonder if there is, if like there's an impact on if people who churn pay more. Or I wonder if there's something about within the fiber customers, those who are fiber customers, when they pay more than the other fiber customers, they're more likely to churn. So we ask these questions. We visualize and we test. And when I say test, I mean like statistical testing, like chi-square, t-test, correlation test. Now this, you're going to get an opportunity to practice this when you go into the project, okay? This is my way of trying to add some structure around exploration. Exploration can feel overwhelming because it's like, where do I start? What do I do? So I spent some time trying to lay out some structure that I've noticed has worked for me in the past. And the first is univariate statistics. And I kind of referenced this morning, but this can be done in the prep stage. I find it's useful to do it in the prep stage because you often find things you need to clean up when you do it, and it's easier to do it while you're already in that stage. But if you hadn't done it at that point, then you definitely want to do it here. And this is about visualizing kind of the distribution. What are the ranges? What's the max? What's the min? What are the counts, the frequency? So when you're talking about like a categorical variable, it's a frequency table and a bar plot, like the proportions and the counts. When you're talking about a continuous or a numeric or a quantitative variable, when we say continuous in this case, we're not usually talking about mathematically continuous, but we're talking about something that is numeric and ordered and not discrete, right? That would be too many numbers to put in a bar plot individually. You can think about it that way. So when we're talking about those, you're talking about the descriptive statistics. What is the min, the max, the median, the range, the quartile 1, quartile 2, etc. And a histogram and or a box plot. Okay. And then of course you want to especially explore your target variable in this. You want to understand all of these things about your target variable specifically, okay? And then you move into bivariate statistics. And so these two pieces, these first two pieces can be, this can be like a script, a helper function that you've saved that you run on every single project you do. And but you don't think about doing that now because you don't have enough like understanding of what you're going to do. But it's something that you're going to do over and over. Okay, these are the more like um, I'm going to go through these steps and do this to get started. The bivariate statistics. This is when you're plotting just a simple X and a Y. Okay, and there are certain charts you'll do for the categorical and charts you'll do for the quantitative or continuous. Um, and then you get into, this is where you start asking the questions. So these two will probably generate some questions. As you do these, you will document. You'll document your questions. You'll document your takeaways. As you go through, you will look at every chart that you've created and you'll see if there's any insights or any lack of insights where you thought there might be. Okay? Because if you don't document, you will forget it very quickly. 2 cells down, you will forget. Okay? So document, document, document. And then once you do all that, you'll probably be, some other questions will come up. And this is where you explore those specific questions. And you may have some questions in the beginning already that you knew you had. And it may be like, oh, I'm curious if, I'm curious if the first class passengers, within the first class passengers, were single males still less likely to survive than the rest, or the non-single males? Within third class passengers, were females with families still more likely to survive than others, or were all third class passengers less likely to survive? You know, you ask these questions. And like I said, you document, you document, you document. Okay. So this will make more sense. This is nowhere right now except on my laptop and in our private GitHub, because I've been working on updating the Explore lesson for this. I will have it to you soon, shortly. Okay. Even if I don't have it up in the curriculum, I'll put a version on the Codeup classroom in the classification exercises so that y'all can reference it. Okay. So let's look at the exercises, and we'll kind of think about that as those things as we go. Remember, the univariate statistics, the bivariate statistics, those are the more the standardized, like I want to see every feature compared to our target. I just want to glance at it, and then we get into the specific questions. The two reasons for viewing these, oh, that's a great idea, David. I will do that. The two reasons for doing these are, or two primary reasons for doing these are, what are our drivers? So what is driving the outcome? And also, are there variables that are interdependent on each other? Are there variables that are providing the same information? And therefore, it is not useful to have both of these variables. Okay, something like that. Awesome. Okay, explore. I have, let's see, I have set up my environment here. Okay. Imports. I've put all my, all the functions in the notebook so that it can be run by itself without, all you would need is the E and V, right? as opposed to referencing a separate file so that we don't run into dependencies when you try to download it and there's differences in the files and stuff like that. So the connection function for accessing MySQL, right? I feel like you all have been working with that one for a while during this module, right? Okay. Here's the query to acquire the iris data. Any questions on these? I think you've been doing this for a while. Okay, cool. We will function to get the data and run the query. We will actually acquire the data. Here's a function to prep the data. So I wanted to show you another way to do a rename. Is I'm just creating a new column, species, and then I am dropping species name with the other drops. So rename, put it in quotes because technically I'm not renaming, but species name to species and drop columns. Okay, and then we will prep the data. Okay, there we go. Is that what your data frame looks like? Perfect. Okay, I'm going to set some default plot parameters. Okay, I'm going to set a default font size and a default figure size. So you can look up this function and see all the different options, arguments available. If you find yourself setting the same parameters over and over and over, you might want to just set a default at the beginning of your notebook. Okay. Exercise 1, split your data into train, validate, and test samples. Okay. So I have imported train test split. Let's take this out of the function first. So I will run, this is how I would write the function, as I would first run it, train test split, and then on the data frame, test size, I'll do 20%, set a random state. If I know I'm going to put this in a function, I might want to set some variables. So I'm going to set my seed to be 1, 2, 3, and then I'm going to reference that here. Okay. I'm also going to go ahead and define what the name of my target variable is. Survive. Oh, not survived. I was working on Titanic earlier. Species. Okay. There we go. So the seed, and then I'm going to stratify by my target. Okay, any questions there? Okay, cool. This will give me train, validate data frame and test data frame. And then I want to do the same thing to split train, validate. So train into train and validate. So train, test, split. And instead of on DF, I'll be doing it on train, validate. And my test size here, I want to make it 30% because I want it to be, it's 30% of the 80%, which is 24% of the original. I want my validate to be larger than my test. Does that make sense? Okay, cool. So random state equals seed, and then stratify on train validate of the target variable. Let me make that a little bit more legible. There we go. Awesome. Okay, so that should work. And size, validate size and test size. Why is it not giving me the shape? That's why. I was like, what's going on? Okay, sorry. There we go. That looks good. That's what I would expect. Cool. So I will go ahead and put that in a function. Train validate into train validate. Okay, so this is to test the elements of the function. Okay, that seems to work. So now I will actually run this. So we have the actual function here, and then I'll run it below. My data frame is named irisdf. So when I run it here, that is good. Perfect. Take a quick look. Okay. And when I'm looking, I usually look to see not just do I have the right columns that I'm looking for instead I would expect, but do I have, is the index no longer ordered and starting with 0, etc. Of course, I can also look at the shape.
Quick question.
Yeah.
I noticed that on mine, and I think I was just like using the previous example to make my prep iris. I put train size rather than test size.
That's fine.
And just specifying that was saying that the train size is going to be 70% of the 80, as opposed to your test size was shaping the validate into 30% of the 80. Okay, cool. Just
You
wanted
can
to
do
make
either
sure.
way. Yeah,
Thank you.
totally. Yeah. I don't know why I do test size. Maybe laziness and it's one less letter. I don't know. Who knows? But yeah, you can do it either way. Okay, cool. So we've done that. Exercise. Any questions on exercise 1? Other questions? Oh, okie dokie. Artichoke. Okay, exercise 2. Create a swarm plot using a melted data frame of all your numeric variables, which is all of our variables. The x-axis should be the variable name, the y-axis the measure, and then we'll add another dimension using color to represent species. And we will, of course, document our takeaways. Okay. Oops, did not mean to do that quite yet. So let's melt our data first. So we'll do train.melt. And our ID variable is our species. Okay. And so now we have our species, we have the variable, and we have the variable value. So as we would expect, variable will have 4 unique values, right? It will have sepal length, sepal width, petal length, petal width. Okay. And how many rows do you think there are? If there were 84 in the original train. You don't have to give me the actual like calculation, but like how would you figure out how many rows there are?
Would it be times 3, the species?
It would be times 4,
The variables.
the variables.
Oh, okay, okay.
Yeah, because now each observation has 4 variables. So now there are 4 rows per observation. Cool. Oops. Did not mean to do that. There we go. So all of these things, why do I ask that? It's, well, first of all, it's a way to make sure that you have an understanding of what's happening with melt. But secondly, it's a good way to do some QA, some quality assurance. Am I getting what I expect? So you know you had 84 rows in the beginning, you know there were no nulls, and you also know there were 4 variables. So when I run that, I should expect 336 rows, and that's what I got. So it's good to do those things as you go. Make sure you're getting what you expect.
Hey, Maggie.
Uh-huh.
Is it, something like that where you have the one categorical and you just do the ID vars? Is it usually best to do it that way instead of having to, I guess, rename the columns, like using a var name and a value name? I don't know, just
So,
when I did it, I did var name as like, oh, variable name type, and the value name was length. But now I said that was
oh,
a step I didn't need to take.
gotcha. Yeah,
So,
it doesn't, if you were going to take this further and do more with it, and
mhm.
there's nothing wrong with that. Like, because then you actually have good labels here
Okay.
as opposed to variable and value. Um, the key is you would definitely want to do that if you're, if you're going to be presenting that you would want to do it if you're presenting that visualization, or if you would want to do it there, or at least when you create the plot, change the labels.
Okay.
The key is that you don't want to make sure you want to make sure you don't spend too much time with the little details when you're just going to like be in Explorer, when you're going to be just glancing at something.
Right.
It's like after you know you're going to use it, then you spend a little more time like with that. There is nothing wrong with what you did. That's great, especially if you kind of like, because it's very likely that, well, I'll speak for myself. It's very likely that I would forget what I was doing, and that I would, and it kind of helps refresh your memory of what you're looking at. So definitely nothing wrong with that.
Okay. Yeah, I kind of got hung up on that for a bit. And like I
And
just
that
had to write, I said to put the like the ID vars, and that was it, and then just keep moving forward.
I would
So,
keep it as simple as possible. If it
okay.
is taking some time, keep it as simple as possible. And then if you need to go do it at some point, you can go back and do it.
Okay, cool.
Yeah. Cool. So we've created this melted data frame, and now we can do a swarm plot of the melted data frame. Our X is going to be the variable name, and our Y will be the actual value. And then we will add a color designation for the species. Any questions on that piece? I'm going to do this because I like it when it doesn't show that at the top, the extra text. Any questions on creating that swarm plot or melting that data? Nope.
What was the size that you used for your swarm plot? Just the figure size?
12 by 8.
12 by 8.
Yes. I generally will keep that kind of scale. So it works for most things. Okay, so takeaways. Most important part of doing these. We don't do these for the sake of just doing them, but we do them to discover things. So what do you see here?
The petal measurements are really good indicators of species.
Definitely. Yeah. In fact, for Setosa, we really don't need anything else. Anything else? What else y'all see? Remember, a lack of something that you don't expect or something that doesn't give you information is still information.
So like they all have very similar sepal widths.
Yes, that's a good one. Yeah, so it's like I do see orange at the top, but is there really like, is that going to be useful? We don't know yet. Looks like sepal length could be useful. Yeah. And another takeaway I had from this was, could petal and sepal area be useful? So maybe sepal width is not, and maybe sepal length is a little muddy, but not totally. I mean, it's pretty useful, but maybe the area of the two, could that add value? So that's something I would wonder after that. Anything else?
If you want a full bouquet, go with Virginica because of the petal length and petal width.
That's really good. I like that. That's really good. Yeah. Yeah, I like that. So, I mean, basically what you're saying is that, and this is about understanding our data, right? I have no idea what a Virginica iris looks like. Maybe I do, I just don't know what the name of it is, right? So Virginica has, Virginica iris have the largest petals. And similarly, Setosa iris have the smallest petals. Those are really good insights. Something else I see is that Setosa, while having the widest sepals, they have the shortest sepals. Setosa seem to have wide and short sepals. Okay, amazing how you can get so much from just like one plot, right? Okay, so exercise 3. Create 4 subplots of scatter plots, 2 by 2. So the first one will be sepal length by width, then petal length by width, and then sepal area by petal area, and then sepal length by petal length. And then of course, document our takeaways. Okay, so the first thing we need to do is we need to compute sepal area and petal area and add it to our data frame, to our train. So we can do this by train open bracket sepal area. So this is going to add a new variable, a new column, sepal area, and that column is going to be equal to sepal length times sepal width. Okay, you will use this a lot, this creating a new variable in this way. Very useful. And then we'll do the same with petal area. Any questions on that?
Is there any way that we could have done that like in one go? Like I know we're able to create 2 rows like with the split, but I wasn't sure if we could do like parentheses and a comma between the 2
You
functions.
use a sign. That's the way I did it. I did it in one go with a sign.
Oh yeah, you can do it with a sign.
What do you
That
mean
is
with a
true.
sign?
Let's see, train dot assign.
Oh, us. I thought you meant like a space sign, like give me a sign over here.
A sign with 2 S's in no spaces.
Oh, okay.
So you would train.
So I do have a question as well. So
Mhm.
I just created a whole new train um, data frame. Would it be beneficial to keep everything on one train, or just keep
Yes,
adding to it, or can
yes.
you? Okay,
Because here's the thing, after prepare, if you were to look at the, go back to the pipeline and the goals of each stage of the pipeline, prepare is, we want to leave prepare with a single data frame that is ready to be explored. And so then if we go into explore and we start creating new data frames with other variables, we're kind of like moving backwards in terms of our goal to getting to modeling and stuff.
yeah. So my theory, I guess, like, okay, I'm gonna make this extra train data frame, and if nothing comes of it, I have the other one just like right on the back, just ready
Well,
to go.
the other one is, it's just as easy to just drop a column.
True.
Yeah. So what you'll end up doing, because there will be other columns, I mean, maybe not in this data set probably, but generally there will be plenty of columns that you're not going to end up using. And so at the end, you'll document these things as you go. You'll say, my takeaways are this, and my action is I need to remove this column. This isn't useful. And you'll do that all at the very end when you can apply it to both train and test and validate. And so you just kind of document those changes that will need to be made. And when you're done with Explore, you can make all those changes.
Perfect. Thank you.
Yeah, good question. The key is keep this as simple as possible. Okay. As opposed to trying to find a way to do it in one line, just do it. At some point down the line, when it's important enough, you'll figure out a way to do it if it's important enough ever. Okay, so just keep moving. Yeah. Awesome. Did I already run that? No. Okay. So now scatter by species. Okay, cool. Create 4 subplots of scatter plots. So what I'm going to do first is I'm going to create a single plot. Okay, I just want to make sure that it works and that it looks like what I want it to look like. So I am going to group by species. What happens if I do this? We end up with basically the unique species. And so for each species and subset, okay, we want to plot. Let me talk you through. Let me do one of these actually. That will be useful. Okay. So what do we get when we are doing this? I'm going to show you. Oops. That would be useful. X is not defined. Oh yeah, that's because I'm, okay. So I want to show you what we're getting. What is this doing? So the subset, did anyone do it this way?
I tried really hard to do Brian's code, but it just wasn't working. And now I tried doing the X, Y, and it still didn't work. So no, I was nowhere near what you got.
Okay, cool, no worries. What happens when we do this train group by species? Well, we get a group by data frame that isn't, can I view this? Hold on. not gonna, I'm trying to figure out how to show you what.
Wouldn't it
what's
just
in-
be group by alone without the print?
What's that?
Wouldn't it just be group by, like calling group by without the print?
No, it's gonna give me the same thing.
Oh, true.
So it's a group by object. I'm trying to, I guess this is the best way to see what's in this. So basically it's what the group by object is doing. I'm not going to try to tell you because I'm going to butcher it so bad. But it's it's giving us, it's breaking everything into each species. Okay, so you know how we run when we do a group by, and we can run like an aggregation after it. So basically what this is doing, so we could do like a sum of sepal area or something like that if we wanted to, and we could sum that. So what group by is doing before it gets to this part is it's breaking this into these subsets, a Setosa subset, a versicolor subset, and a Virginica subset. Okay, and so what we can do with that then is we can loop through each subset and plot it. Okay, so if we first want subset of, we want the subset and we want the sepal length column, right? Let's look at sepal length and species just so you can see it. Uh-oh, my bad. The bracket issue. Okay. So now you see, instead of all of those columns, it's just giving me sepal length and species. Okay, for each of these, right? And so we're saying we want to plot the scatter plot of sepal length and sepal width, and the label is going to be species. So what it's going to do is we're going to just pull out sepal width and species, just like that. And we're going to plot this. And the reason we've broken it up is so that we can then say, I want for each of these, first plot one with the color, then plot the other, then plot the other. Okay, we're looping through those. So our X in this case is our X is sepal length and sepal width. Okay, let's do that first. X is sepal length, Y is sepal width. Okay, so it's scatter plot of sepal length, sepal width for each species. We're plotting the X, the label X, which is sepal length, and Y sepal width. I feel like it should be opposite though. I feel like width should be X and length should be Y. Except how is it put? Oh, yeah, that's X by Y. Oh, well, I'm going to do it this way. Yeah. Any questions on that part? Okay, so now we can put this in a function so that we can do this for each of these, right? Okay, so let's do that. So now we can do scatter by species, X comma Y. And then we'll loop through each of these. Okay. And let's try it. There we go. Okay, so we did one plot. Any questions on that? No. Okay, so now how do we do subplots? Well, we can do, remember what these are? This is saying I want a 2x2, 2 rows, 2 columns. And this next plot is going to be in the first spot. And I'm going to run that function. And then I'm going to do it again. And the next one's going to be in the second spot and third spot and fourth spot. And then X times Y, X by Y. The tight layout is just going to clean it up, make it look nice and pretty. Okay. Any questions on that one?
I tried using the label species because like I did not use a function, and I had to try and just do a regular subplot, but whenever I put that in, it wasn't working. Am I supposed to specify where, like the data frame that species is being pulled from?
Did you add a plot legend?
Duh. All right, you got me.
Cool. Awesome. Perfect. Any other questions? Damn it, I forgot to record.
It's being recorded. I'm not.
Oh,
Oh, I think Ryan is.
Ryan, you're my
Rescue.
hero. Thank you. Thanks, Faith. Okay. Takeaways. Well, here's some takeaways I had. Simple length is actually useful. So when I look at sepal length and sepal width, remember sepal length, when we look at it horizontally, we see some division, right? We see it starts with blue. So imagine if we took all of those dots and we smashed them together to one horizontal line, we would see some division. We would see blue on one side and green on the other and orange in the middle. Okay, so that's how I'm saying that sepal length is useful. Sepal width, so imagine the same, but we smash it like this. Okay, we smash it into one vertical line. Do we see some division? I mean, yeah, between the orange and blue, we see division, right? Somewhat. Orange and green, I mean, there is some, like green's a little higher, orange is a little lower. It's not as clear as these, obviously. And then blue and green, yeah, there's some. Yeah, it looks like there's some division. It's just not. This is more realistic than like regular data and than these and like normal data sets that we would see. So width is not great. I'm not sure if it would add value or not. We might need to do a statistical test to see. Petal area, as we would expect, is very useful. So let's see where petal area. I mean, yeah, so when we look vertically, right, we see clear divisions here, as we would expect. When we look at sepal area, we don't see so many clear divisions, right? It's like, I mean, yeah, we see green goes a little further over that way and orange goes a little further that way. So there is some usefulness in green versus orange, but okay. So like I said, sepal area is questionable. We don't see much separation. Some value in sepal width, but not a ton. Any other takeaways?
It was pretty much the same as what you came up with. So
Cool. Okay. And then, you know, what we already said, we said that Setosa are the smallest petal, have the smallest petals. And Virginica, the largest petals.
I thought
Looks like,
the sepal length, that petal length was pretty good as well.
yeah, petal length is awesome. Looks great, right?
Yeah.
Sepal length, you can see here. Yeah, this is a good example of sepal length providing some value, because you can see that, you know, when I look at these things and see these, I think of a decision tree. I think a decision tree is going to be useful because I see rules. I see we first divide by sepal length, right? Or by petal length, because there's a clear division there. And petal width, we first divide by petal length and petal width, or petal area or something like that. And we classify those because it's really easy. And then we get into like adding some information about sepal length, right? Where you can kind of divide right here or something like that. So if sepal petal length is less than 3, less than 2.5, then it's going to be a setosa. So you kind of think about rule-based models, which is a decision tree. And we'll talk about that later, Monday, probably. Okay, exercise 4, create a heat map of each variable, layering correlation coefficient on top. Okay, I want to add this note. Please, 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 and there's a reason I say this, it's because it's always done. Please don't put a heat map like this in a presentation, okay? This is great for exploration. And maybe a heat map with not too many variables might be good in a presentation on a rare occasion, but not with all of these numbers on here. Okay. No one really needs to know the difference between, in a quick presentation, 0.96 correlation of 9.6 versus 8.7. They're generally looking for comparison. Okay.
That really makes me laugh because my heat map looks just like yours. And I was all proud. I'm like, oh yeah, like I used cool warm and annotation's true. And
no, it is good. No, it's a good heat map. It's a good heat map for exploration.
Yeah, and I'm glad you said not to put it in presentation. I probably told you to like slap that up there, like, oh yeah, look at this.
Oh yeah, no, everybody does. That's why I said it.
Center equals 0 do? I didn't put that in.
Center equals 0 is centering your gradient, where the center gradient, the like middle of the gradient, sits at 0.
Okay, sweet deal. Thank you.
Yeah. So if I did this, you'll see how it shifted. And it's mostly blue, right? Up until 0.5. Yeah, it's pretty cool. There are plenty of cases where you don't want that center at 0. So, and then if your correlation isn't, so the reason doing this is that, you know, the correlation isn't going from 0 to, it's not technically going from -1 to 1, because we don't have a -1 correlation, but we do have a 1. But we really want 0 to be that center, because that means no correlation, whereas -1 means 1 and means a negative correlation, and 1 means positive correlation. So we want that center to be right at 0. Okay, so we are, I want to make sure we get through this before lunchtime. Train.course, so we're creating the correlation, we're computing the correlation coefficients, and then we create the heat map, sns.heatmap. Okay. Annotate is adding the correlation coefficients on top of it. Okay. Takeaways on this is that my takeaways are that most measures do correlate with each other. Really, the only one that has like basically nothing. I mean, petal length and sepal area is really low stuff, but sepal width and sepal length, which is so interesting to me, that there's like no correlation in that. Why do I say no correlation in that versus -0.48? Because that's leaning towards a negative correlation. Okay, so my takeaways are that there's like no correlation there. Negative correlations include wider sepals seem to lead toward shorter and narrower petals, so smaller petal areas. And some positive correlations, longer sepals seem to lead toward longer and wider petals. Okay. Little to no linear correlation is sepal length and sepal width. Now, remember, what we're measuring here is linear correlation. That does not mean that there's not a relationship between sepal length and sepal width. There's just not a linear relationship. Okay? So please, please, please remember that. Okay, exercise 5. Create a scatter matrix, visualizing the interaction of each variable. So we will do pandas plotting of scatter matrix. And let's show that. And that's what we end up with. Okay, nice, because we can see the histograms in the middle. We can see the distributions. And we can see, like, as we would expect, petal width and petal area are highly correlated. So we should be able to look at this and look at this heat map and see a strong linear correlation when we see a bright red, right? So let's look at sepal length and sepal width. Sepal length, sepal width. Yeah, I mean, there's, I don't know what it is. Something maybe, maybe not. Nothing I can tell right now. I could also plot this using the Seaborn's pair plot, which I love. Just be careful doing these when you have too many variables, because you will time out your computer pretty quickly and everything will crash. Okay, so the pair plot of train and our hue is species, which is really nice because then I can look and I can see. So I have a question. Oops. Oh, by the way, if you didn't know, you can double click right here or click and it will like shrink it. Double click, it will shrink it to nothing. Single click, it will expand it again. Can you go away, highlight? Thank you. Okay, so here we can see petal length. When you think about, I hate that I'm hitting time. I'm not going to finish this. I have an appointment I have to go to at 1. So what we're going to do is we are going to come back and our vendor is going to, after lunch, start the evaluation lesson. Okay, so y'all are going to go through the evaluation lesson. And after you're done with that, when I get back, we'll finish up these because I don't want to rush through the last 2 problems. And so we'll finish up reviewing this after we go through the evaluation lesson. Does that sound good, Ravinder? Okay, perfect. Because it is lunchtime and this is really important. So y'all good with that? Awesome.
Thank you for
Okay.
not rushing through it.
Oh yeah, sure. Okay, cool. So y'all go take a great lunch and we will see you this afternoon.